Good morning, physics folks. How are you guys? We are going to go over numbers 12 and 13 together. So if you take a look on page 210 on number 12, let's take a look at it. If a torque of 55 Newton meters is required to turn a bolt and the largest force you can exert is 135 newtons, how long a lever arm must you use to turn the bolt? Well, remember, let's just write down everything that we know or everything that's given. So in number 12, what is given is the torque as 55, force is 135, and we don't know the lever arm. So we can use this very simple formula. Torque equals FL, force times the lever, because they don't give us an angle. That makes it nice. So now I'm going to go ahead and, hold on one second. Sorry. So now I'm going to go ahead and put in torque is 55 equals 135, which is my force, times L. Well, I want L by itself, so I'm going to divide by 135, and I have to do that to both sides. So this cancels out, and I have 55 divided by 135, which gives me a lever arm with a length of 0.41 meters or 41 centimeters. Okay, so that one was nice and simple. Okay, number 13. It's a little bit different, but I'm here to help you right along. Now in 13, we are going to have to find the angle. They give us a 0.234 meter long wrench, and the job requires a torque of 32.4 Newton meters, and you can exert a force of 232 newtons. So first of all, what's the smallest angle? Ignore where it says smallest. All you have to do is find the angle. A lot of times they throw words in there to make you think that it's not as straightforward as it is. This is straightforward. You're just going to find the angle. So if you come over here, you write down everything that you know, correct? Now, I set it up. I know this looks crazy right now. Let me set it up for you again. So we have torque is 32.4. I'm going to leave out the units right now. And that equals, what's our force, is 232 newtons times the R, which is 234 meters times the sine of theta. Now, what I do is I go ahead and multiply these two things together. And when I multiplied those together, I got 54.28. And so I can divide by 54. Whoops, I'm giving you the wrong spot. 54.28. And then that cancels that out, and we're left with the sine of theta. Then over here, I have to divide this side by 54.288. Now, I want you guys to divide that. Just 32.4 divided by 54.288. And then you should get this number, 0.5968. Well, that is equal to the sine of theta. Remember, the sine of an angle gives us a decimal. So now we're going to have to use inverse in order to find the angle. So in your calculator, if you put 0.5968, then second sine, which is the inverse sine, you'll get an angle of 36.6 or about 37 degrees. Okay? Let's try the second part, just as another practice. It's going to be the same equation, And the only thing that we're going to change is the force, because it says that your friend can exert more force than you, so 275 newtons. So again, we are going to find the angle. So this is how I set it up. And originally, I just had torque 34.4 equals, and then the new force, 275 times 0.234 meters times sine of theta. Well, I'm going to ignore sine of theta, and I'm just going to multiply 275 times 0.234 and then divide it. And then that is going to cancel that out. Whoops. And then you bring it over here. What you're going to end up with is 32.4 divided by what this answer is, and that is 64.35. That is equal to the sine of theta. So you know we're going to end up with a decimal, correct? Absolutely, Dr. McKean, you are right. Yes. I love talking to myself. So you're going to do the inverse sine of what this decimal is. This decimal is equal to 0.5034. So if I do the inverse sine, or a second sine 0.5034 equals, it's right around 30.2 degrees. And if you wanted to keep it at, no, we're going to keep it at 3 sig figs. So that is how you do, and let me zoom back out there. That is how you do those two problems. If you have any question about that, please email me. Please leave a comment. I really like your Torque Talk videos. Oh my gosh, they're great. Ashley, holy cow, yours made me tired. But everybody's, I really like them. So I'm going to hold off, and we're going to go over, let's see, something a little bit different. We are going to go over net torque. And I know that this looks a little bit scarier, but I promise that we'll get through it just like we do everything else. And if I find that this part is a little bit too challenging, there are only a couple of problems. So even if we decide to kind of skim over this section, you'll be fine. You'll be fine. But I want us to at least do the sample and one of the problems over here. So I will leave that until next time. So you guys have a great evening. Bye-bye.